See the cloud sync icon? That's turning. That means it's communicating with the cloud, either sending data up or downloading data. In this case, it's probably downloading what I just did, that prescription. So if I go to map, I'll show you, we have that sprayer coverage. I'll go to that same field, sprayed field. So if I go to the map selector, you can see there's standard. Those are all the ones we've talked about so far. If I've imported prescriptions, like we just showed, or imported other shape files, I can slide this over and I can get sprayer coverage. And that's what that shape file looks like. You can see basically this is a similar map. So the value of that would be I could put it in split view, sprayer coverage and hybrid. See that outside and the ends are one hybrid there. Does that really match up? Well, we already know, since this was harvested with yield sense, you already know from what we saw on the website there. But here you can have them side by side, and you could have had the sprayer coverage up as you were harvesting, making the pass where it wasn't, where the check strip was. There's one other field I've got a shape file for. That's a variable rate nitrogen side dress shape file. So then, where the shape files become really beneficial is when you're using yield sense as well. We'll put it in split view and have yield beside nitrogen application. We'll be able to line up the crosshair on a split between a higher rate and a lower rate and see if it affected yield in any way at all. So here, let's check. Right there was the yield affected by the lower rate of nitrogen. Looks like it was in some fashion. What about over here? Looks like it potentially was there. Here's a lower area. Okay. So you can start to begin to see those things. Keep that out of split view. There's two prescriptions that I made there. So there we can see. That's the one we just made. 38,000, 35,5, and 34,5. Now with V-Drive or row flow, the planner would control through that prescription. So Air Force is plan-wide adjustment of airbags automatically. Delta Force is individual row adjustment of hydraulic cylinders automatically. So the concept behind them is somewhat similar. The way they control is very different. For either one, you're going to have this button. So if you have Air Force or Delta Force, you want your shortcut button there. When you first start in the morning, fire things up, it's going to be disabled. So yellow is that flashing orange box around it. That's for Air Force or Delta Force. If you shut down for lunch, come back out and start up again, same deal. So I need to first enable it, then I need to set a target. And there's two different ways I can set a target. One is from 2020, the other is from FieldView. So basically what Air Force controls to is margin. So it's controlling to the minimum weight that you've told the system you want on your gauge wheels as averaged across the rows that you're measuring in the last 3 seconds. Okay? So I can set it in standard mode like it is right now, 30 to 80 pounds. So it's going to try to keep the least amount, the lowest readings of the gauge wheels in that range of 30 to 80 pounds. It's a wide range, and always will be, no matter what setting, because we're averaging across the planet. Alright, so there's going to be some row-to-row variation. We're controlling every airbag on the planner, every down bag to the same PSI, and then with lift bags, every lift bag is at the same PSI. Right? So there's standard mode, there's heavy mode, 80 to 120 pounds. So it's targeting to run more weight on the gauge wheels. There's light mode. See, the target shoots for less than 100% ground contact, meaning if you plan in light mode, you're targeting to have shallow planes. So light mode is I'm not going to say never, but 99% of the time it's not a good idea. In peat soils, if you're planting when you know you shouldn't be and you can barely pull a planter through the field because it's so muddy, light mode might be a place to be. So there's light, standard, and heavy. Standard and heavy are things you might run in. There's also a custom mode. So with custom, you can stretch or squeeze that target. So how wide do I want that to be? We stretch it out. We can make it that wide if we squeeze it and tighten it up a little bit. Now I have the ability, I can adjust it to the right, to the left, however I want. Custom allows me to fine tune a little bit more. Now from the iPad, there's not really a mode that you would adjust. You would just adjust your target range. So you need to enable it and then set a mode. There's a hold button over here. Right now it says cancel auto hold. If you touch setup on the right side, there's some Air Force setup in here. There's an automatic hold button up here. I would disable that personally because what will happen if one row doesn't plant or clutches fire, it stops adjusting your airbags. And you don't do anything, it stops adjusting for a time. So I would disable that on this control page or on the home screen. There's a hold button, and that's manual. So let's say I'm planting right now, I'm coming up to a waterway. And I'm going to slow down and go through that. Now, if I have 4-inch deep field cultivated ground I'm planting in, and I get to sod, I really don't want the system to adjust the airbags based on what the sod is in the waterway is, because I get to the other side, it's going to be way too heavy. So if I'm coming up, my front tires get to the waterway, I can hit that hold button once, and it will stop the airbags from adjusting for 5 seconds. If I hit it twice, it'll do it for 10. If I get there, now I'm not quite through the waterway yet, I hit it again, and it'll add 5 more seconds. So I can keep the system from reacting for how I want to, but I'm telling it when I want that to happen. Or automatic hold, like let's say when clutches fire, I think is one of the events that cause it, it just automatically stops reacting. So that's the basics of how it's set up. If I touch on the Air Force button down at the bottom, I can see my tank pressure, the pressure in my down bags, and the pressure in my lift bags. As that's adjusting. The green bar is what's actually present. The black is the target pressure, what the system is commanding. So that's just informational. You don't adjust that. That's just a, hey, what's the system doing right now? How would you use this? How should you adjust Air Force? So with Air Force or Delta Force, it's not, I mount these components on my planter, I enable it, and I plant, and everything's always perfect, and I never have to mess with anything. It gives you the tool to set your target gauge wheel weight so the planter is running as optimally as it can for the conditions. How I would do it is I would probably, what I found over the years, probably with Air Force, I would enable it, set it at 40 to 80 pounds with custom. I'd go to home, and I come back to my FieldView, and after I've planted a little while, I'd watch my downforce map, and if I saw a solid blue, I'd change immediately. But if I saw a little blue, some red, some green, I'd plant for a little bit. Now your end rows are going to be always harder than the middle of the field, and there's all this variance, so I'm speaking very general terms here. I'd plant for a while, 5 acres, 10 acres, check this report, and if I see my loss of ground contact with Air Force higher than 5%, I'd probably increase my target. Now I can very easily do that. If you had Air Force, this would say Air Force. I can touch that, and with Delta Force, it's one number. With Air Force, it's going to be a range. If I see my loss of ground contact too high, I can either touch that slider and move it with my finger, or use the arrows. So if I'm at 40 to 80, if this was Air Force, I could hit the button to the right, and it would go to 50 to 90. Hit it twice, it'd go to 60 to 100. So if I see loss of ground contact well above 5%, I'd increase my target. continue to plant, and see if my loss of ground contact is going down. In the same way, if I see a very low loss of ground contact but very high excess, I probably reduce my target a little bit. But what's the wrong way to use air force? So a couple weeks ago I was at a meeting similar to this. The guy said, hey, can you look at my maps? I don't know if I'm getting everything I should out of Air Force. I run 2020, I run FieldView. I said, okay, well, how do you adjust things? Well, I watch the 2020, and anytime I see the ground contact get below 100%, I go in and increase my target. So a lot of times I run like 120 to 160 pounds as my target. So you look at his FieldView maps, most of them he had like 0.8% loss of ground contact, 40% good, and 60% excessive. I'm willing to give up, with a planner-wide adjustment tool, I'm willing to give up 3 to 5% loss of ground contact to get my excessive from 60 to 20. Right? So remember, loss of ground contact, I have the potential for no ear on the plant. Excess weight, I have the potential for a smaller ear. What numbers should you look for? Around 5% loss. Good is going to be, say, 75 to 85. Sometimes higher than that, sometimes lower. And then your excess would be anywhere from, 5 to 30%. So I'm going to show you two different farms right beside each other. We'll look at downforce. Now this is gauge wheel weight. So the downforce map on FieldView is created the exact same way if you have 2020 only, 2020 with Air Force, 2020 with Delta Force. The methodology for determining what color to make the square is the exact same. If I have Air Force, I should have more green than if I have manual. If I have Delta Force, I'm going to map every row compared to Air Force or just 2020, it's probably not every row. So this field, so all this plus this long narrow 40 was all originally one field owned by this guy. This field was planted with a John Deere 1760 individual row hopper planter with down and lift Air Force in strip till, fall strip till, right into the strips in the spring. All right, so here's our downforce map, a decent amount of red. We look at the report, 3.7% loss, 70.5% good, 25.8 excess. Can't say it was operated poorly here. If they had backed the target off by 10 pounds, the loss would have gone up. Could the excess have come down another 5 or 7% and the loss gone up 1.5? I don't know. Maybe. Might have been worth trying. This is not run poorly. It's planner-wide control. If we zoom in and look at some different spots in the field, and let's just zoom way in and look at individual passes as close as we can, let this clear up, we can see that in this pass, one row had well over 200 pounds of gauge wheel weight. When 2 rows over, there's a little bit of loss going on. It could be, it's not a planter thing because I don't see the same pattern across. Could the knife in that row in the fall then run a little bit deeper in that spot? I don't know. Was the row cleaner running less aggressive here, more aggressive here, and removing weight off the disc openers here? Whatever the reason, you can see it was averaged pretty well across the planter, but there's still row to row variation. So that's this field, strip till, 70% good with Air Force. Now with Air Force or Delta Force, we have the applied force map, and this is the net force that's being applied. So if you have down and lift airbags with Air Force, there's going to be pressure in the lift bag and in the down bag at the same time. So we are mapping here what's the net, the down, the lift, what's the net actual force applied down or lift. Same way, Delta Force cylinders always have lift and down pressure in some amount. So we're mapping the net from that, right? So here we can see, right here along the pipeline, over 200 pounds of force is being applied down. over here in this area. It could be that it was set a little bit lighter, or it could be that the hoppers were pretty full of seed at that point, whatever it is. There's hardly any, basically 0 to 25, and 0 to negative 25 means lifting. So that was basically running with no extra weight being applied down and then a little bit of lift. So it was mapping that kind of line. All right, so we can see the net force. Now, I'm going to select this field and make it active. And go to the downforce map. This was planted with a 16-row John Deere 7200 with down and lift air force. So 12 rows, 1760, hoppers down and lift, 16-row 7200, hoppers down and lift. Virtually the same planter, except 16 versus 12. This is conventional tillage. So cow manure in the fall, deep ripped in the fall, 2 soil finisher passes in the spring. What we just looked at was fall strip till. Look at this report. 1.6 loss, 95.9% good, 2.5% excessive. I would not expect to routinely see that number or anything close to it with air force. This is very, very high for air force. But it's a very mellow seed bed, it's got down and lift capability, and there's consistent weight across the plant. That's why it's able to do it. With central fill planters, with strip till, with no till, you're not going to see numbers this high. So if we zoom in here, there's still row-to-row variation, but a little bit less. The other thing you see here is they're mapping a higher percentage of rows, so they're measuring more rows. So regardless of your downforce control system, if you don't have delta force, consider with either air force or just a 2020, it might not be a bad idea to add a few more load cells. Not necessarily because with air force it will control that much differently, or manually adjusting, you'll be able to adjust it much differently, but the map you see will give you more information because you're picking up more rows. Especially if you have 2020 only and you're just measuring 3 rows, think about maybe purchasing a couple more rows worth and adding to it. So out here, you're like in this spot, that looks very, very good. You know, over here, there's some variation. Looks like maybe something's going on a row. Here, here. See, that's the thing. If I'm measuring 3 out of 16 rows and I don't have a weight pin on that row, I don't see that that one's running heavy here, and right there, and right there, and there. What is it? I don't know. I expect to see this more because the planter was folded up and took a turn a little too short pulling out the field entrance, and the wings kind of caught the ditch. So I got done milking one night last spring and walked out and I'm like, why in the world do I have a skid steer hooked to the row unit with a chain? And they're like, well, it's not quite 30 inches apart, pull it some more. So we'll see how the planter runs after those steel row units got bent a little bit. But I expect that they're going to add the other 3 rows here, so every row will be measured. I expect to see more variation this year with a bent row unit on would be 5. So that was the downforce. What's the applied force? You can see here, the lightest green, like up here, is 0 to 40, and the darker green over here is negative 40 to negative 80. So this planter, in the mellow, conventionally tilled ground, was lifting most of the time. Here's a field. The first field we looked at is typical of air force and no-till, strip till, that kind of thing. This field is going to be typical of air force and conventional tillage. So this was a 24-row 1770 NT CCS planter. We can see fairly consistent. You can see in the bottom left corner, that's where he pulled in the field and turned around and unfolded. You can see the wheel tracks there when we planted across that. You can see where a tile line was put in. We can see this outside pass up here that was on a hillside, where the planter shifted down the hill about 15 inches, and the row units ran in the wheel tracks. There's a lost ground contact on the center. 24 rows adjusted based off of measuring 12. There's still some loss of ground contact and some excess. So we look here. This was adjusted to 2.6 loss, 83 good, 14 excess. Probably could have backed the target off 10 pounds, gone up to 4 or 5% loss, maybe dropped the good to 10, but still here, not bad. Now with Air Force, I've talked about planting in good conditions. If you're planting when it's very, very dry, you want to run hot, more weight. If you're planting when it's very, very wet, I should run a little bit lighter. Okay. So the drier the soil, the less extra weight hurts. The wetter the soil, the more extra weight hurts. So just kind of to review, enable the Air Force system. I'd probably set it at 40 to 80 if you're new to it. If you know what you've done in the past, do that by all means. Plant for a while, watch my FieldView report, increase or decrease my target based on what I see. I'd rather have more excess than loss. All right, so Delta Force looks very similar. Starts out disabled, touch, enable. Now you see with Delta Force, because every row is controlled individually and every row is controlled, where Air Force is slower to adjust because we're adjusting all the rows based off of some of them being measured. That's why a section controlled system that adjusts very quickly based on 1 or 2 readings could be kind of scary. So if I'm adjusting 6 rows on the wing based on 2 readings, and I adjust it, I can move it 100 pounds within a second. If I've got 1 reading that says I need another 100 pounds, the 6 rows slam them down immediately. Well, what if 1 row needed that extra weight, 5 didn't? Now I've got 5 rows, 100 pounds too heavy. All right, so that's why we went with the individual row control of Delta Force, is because then we can adjust very quickly and know that every row is doing the right thing because we're not averaging or we're not adjusting 6 rows based on 1. Delta Force, every row is measured. That cylinder reacts based on the measurement of that row. So with Delta Force then we can set 1 point, 1 number instead of a range. So we can move it all along here. So standard mode is 100 pounds. Now with Delta Force, the weights are a little bit heavier, the targets are a little bit heavier, and the reason is because this is a different measurement. Where Air Force controls to the lowest measurement in the last 3 seconds, plantar average, this is controlling to the average downforce sub-second. So if I take a kind of a sine wave, a chart that maps my points, they're constantly changing up and down and up and down. Margin, with Air Force controls to, is I go to the bottom of that in 3 seconds, find the bottom, and I control that. Delta Force is, here's my 3 seconds, I move that down to 1/5 of a second, and I find the average or the center, not the bottom, but the center, and then I control that. So with Air Force, we might have amplitude like this in 3 seconds. With Delta Force, because we're controlling so quickly, we can control the average instead of minimum because the amplitude is going to be shrunk way down because it's such a short time frame and such quick reaction. So 100 pounds of gauge wheel weight in 1/5 of a second is actually less than 50 or 70 pounds of lowest gauge wheel weight in 3 seconds. Air Force adjusts every second based on the last 3. Delta Force adjusts every 1/5 of a second based on the last 1/5 of a second. So with Delta Force, it's basically, what's the gauge wheel weight right now, and right now, and right now, per row, 1 number. Standard's 100 pounds, heavy is 150, light is 50, and then custom, I can put it wherever I want. Just move left, move right, and 10 pound increments. Okay. There's also for Air Force, Delta Force, a manual mode, which defeats the purpose of having the system because this is back to how much force do I want down rather than how much gauge wheel weight do I want. So Air Force, We would set, watch the map and adjust with delta force, basically the same way. Set it, go back to FieldView, enable delta force, set my target. I'd start with 100 pounds, which is standard, or you could put it in 100 custom. Go to downforce map. Check my report. It's right here, 0.5% loss, 99.4% good. Now, that's pretty darn good. If you want to split hairs, increase your target by 10 pounds, because you're better off to have 0.5% excess and 0 loss than you are to have 0.5% loss. But that's kind of splitting hairs. If I need to change it, I can do it on 2020, or right here, touch delta force, and I can slide this wherever I want, or use the arrow. So if I need to increase my target, just bump it up to 100. Or if I was in standard start, 110. This was planted with delta force last year. The entire field was planted in standard mode, 100 pound target in strip till. Looks fairly green. That's what we want, is a green map. But we zoom in here a little bit, you can see, there's a little bit of blue. We touch the report, 5.6% loss, 95.3% good, 0.1 excess. So I just said you should be able to achieve 97. This didn't. But the target was 100 the whole field. If I see this and I'm up to 110, 120, I bet we could get this up to 97. Okay. Now, once again, this was strip till, fall strip till, come in, plant it in the spring. With air force, in that previous field, it was 70% good. In a similar situation, this was a 16 row hop planter. Now with delta force, just set in standard and go, it's 94. So delta force is always a better control system. It's not really necessary. Like that one field I showed, we actually had 95% good with air force in conventional till. Yeah, so here, you come in and you see this, you'd want to increase your target. Very simple.
What you should have did is plant about 5 acres of that field, see this report, slide that, increase it 10 or 20 pounds, slide that to instant and see what happens,
Yeah. Yep. So you can see here, what are some things that affected the delta force system? Well, you can see a wheel track going across there. So that's actually where there's some lots of ground contact from the four-wheel drive tractor after it applied anhydrous in the fall, folded up, driving across it. So you can see that. So you might say, well, I thought delta force would react for wheel tracks. Yes, but no. So if we zoom in here pretty tight, right there, that's 1/5 second loss of ground contact. There's 2/5, and this is like almost a second on those couple rows. A higher target would have helped it. But see, we're hitting these at an angle. So basically, here's a track here, and we're hitting it like this. We can't predict what's happening. We're only sensing and then reacting very quickly, mind you. But if we sense that we're losing ground contact and we need to adjust, well, we have to sense we're losing ground contact before we can adjust. So there's going to be some loss. Now, if we were to have, see here again, going across a spot, there, you can see some loss. But if I'm planting this way, and the floater just ran this way, and this row, 2 rows over and 2 rows over, getting the floater track the entire way, they're going to be at the right depth, because I'm constantly measuring that. And that row might have 400 pounds of downforce applied. This row between the tracks might have 150. This row might have 350 in the other floater track. This row might be lifting 10 pounds, and this row might have 210 applied. But when you hit something perpendicular or at an angle, it's going to react, but you're still going to lose. You might have 2 or 3 plants that might have been planted shallow. We look at applied on this field, especially right in here, with delta force, the applied force is 5th second row by row. So you can see, you zoom in tight where that wheel track was, we've got some rows running up here that were lifting up to about 50 pounds. And then we've got these rows of wheel track applying over 200 pounds. So if we zoom out, you can see it definitely reacted, changed its total force by a couple hundred pounds there for the wheel track, but it had to sense it first, then react. So if I cross a floater track, I'm going to have probably about half of it where I'll have some shallow planted seeds. Also here, we can see on this end row how compacted that end row is and how much force had to be applied there. So with delta force, you truly, in a sense, get a soil hardness map in a way on the applied force. The only thing that would make it not really that is if you had individual row hoppers full of seed versus empty. So this is a little bit more telling you where the harder and softer spots of the field are. You can see all these end rows are pretty compacted there. So zoomed out on that, I think it's about 80 acres. Looks very consistent. And if we hit the report, 98.8 good, 0.7 loss, 0.5 excessive. Really good. Once again, you really want to split hairs, another 10 pounds of target may have switched your 0.5 or 0.7. But that's splitting hairs. I mean, it's very good. When we switch, look at the applied force. On this one, you'll be able to pick some things out here. Tillage was done at an angle through here. You can see where it was reacting for that. And you can see where the quad track turned around down here on the ends, and it was adjusting for that as it planted the end rows. Air force or delta force or even manual, the methodology that I would use to set my downforce system is the same. Set it at a beginning setting, plan a little while, watch my report, increase my target for air force or delta force if I'm losing ground contact more than I want to now. We're talking probably 5% for air force or manual, probably 1.5% or less for delta force, maybe 2%. And if I see the opposite, I see too much excess, I would decrease my target or decrease my airbag pressure or spring pressure, I would do it manually. So this field, you can see it looks different on each side. The prior year is farmed by 2 different people. Then in 13, it was all farmed by 1 person. The prior year, this half was seed corn, this half was commercial corn, that was alfalfa. So you might be able to figure out where this is. Any idea why there's a lot of lift here and here? It has to do with the seed corn being in there. So this is lifting, so it's mellowing ground. Commercial corn beside it, you gotta have soybean isolation. So this was beans over here, and that was beans. So the corn after beans was a different environment than corn after corn. So you can see how it adjusted there. It was lifting more. You can also see where they trenched across and moved the center pivot to make it a full swing in the middle, just a half swing over there. And here you can also see where they assembled that pivot. Trucks drove in and out. The delta force system changed. It was applying. We got the downforce map here. Here we'll see kind of a common theme again. This was very good, but there was more loss of ground contact than there was excess. So another 10 or 20 pounds of target would have been helpful. All right. Yeah, so here, see 96.3% good, 3.2% loss, 0.5% excess. Another 10 or 20 pounds, I would put it over 97. The other thing to look at, once you get things set well, could be look at the individual rows. That top one, obviously something's up, whether it's a row unit thing, whether it's a downforce sensor, whatever it might be, something's not quite right. Get set for what you see at the bottom, but then if there's rows that are way out of whack, try to dive in, see what it might be. All right. V-drive. So row flow is a system that will control hydraulic drives and or swath control via row clutches, half-width disconnects, or hydraulic drive disconnects. V-drive then is electric drives, one in every row. Removes the drive system to swath, turn rate, turn compensation. This button for row flow and V-drive, everything, it'll either say row flow or V-drive, but when we touch it and go to the control page, everything in here is exactly the same for both of them except for one thing. And I think I can show you what that is. Basically, it's section control with V-drive. So if I touch on that button, I get to this control page. If I have a prescription loaded, like from my planting plan, or on the iPad, under the control page where I would select hybrid, it's going to say variable. I can see my map here, see the different colors of the rates. It's going to show me what I'm currently planting, and then the next is the next population it's going to come to. Alright? If I'm using a manual rate, not using a prescription, but controlling hydraulic drives manually or V-drive just manually, I can touch this to change it, or if I don't have a prescription, it'll automatically be on this. And basically here, it's manual. My commanded population is right here, 29,000. I want to adjust it, plus or minus. I can touch that and increase or decrease. Over here, these are my set points. So if I touch 35,000, it adjusts that to 35,000. If I touch population set points up top, I get in here to where, let's say I can put in 28,000, 30,000, 32,000, 34, 6, 38. Alright. What I just put in there doesn't actually change my population, but it sets up my options that I have in here for manual control. So I can do 28, 30. I can just touch those buttons going to 34. If I want to actually plant 35, I can touch here and then do plus 500 twice for 35. Single, we have the ability to set up here where you can control your left motor, right motor, and even center motor if you had 3 for hydraulic drives. Plant a different population for each. So here I could plant 38,000 on my right motor and 30,000 on my left. Now I might want to do that if I had 2 different hybrids or something. Or I can go back to multi, and now it's going to have the whole planter plant a certain one. Now, the V-drive, you can set up drive sections. It doesn't have to be left-right. It could be rows 1 through 4 is one, 5 through 8 is another, 9 through 12, and then 13 through 16. Or guys plant seed corn might have all their female rows on one drive section, males on another, and if you plant a half-rate male on the outside too, put that as a 3rd drive section. And then in here, you could set each one of the drive sections to a different manual population with V-drive. So if I want to plant 35,000 for females, 32,000 for males, and 15,000 for half-rate males, I'd have the option to manually set those up and do that. So we don't have to change sprockets, don't have to plug holes in discs to do those different rates. We've got the demo field. If I touch this button for row flow or V-drive, I would say V-drive, and pull this up, if I'm manually setting my population, this right here, just as with a ground drive, it's my target set point that I'm monitoring from. I put in 34,000. With row flow and hydraulic drive and V-drive, now it's commanding 34,000. Now it's commanding 35. And I would need to hit confirm at the bottom. Then it would change my target, what I'm planting, to 35. So I can do it from the iPad or from 2020. Just the same way here, if I was variable rating, this would say variable rate, and I'd have my prescription and attribute loaded in there. For swath control, either V-drive or row flow, Enabled here means it's going to swath off when you get to either a boundary or an already planted area. You can see down here, these green boxes are clutch status indicators. When they're green, it means the meters are planting. When they're yellow, it means the meters are not planting. If I, for some reason, want to change this and control it manually, I can just touch where it says enable. And now I can clutch from right, clutch from left. And you'll see it change here on the map. I can touch this manual section control. And see, now it's planting some but not others. Out in that boundary, I go back to enable. There, just shut off, they're yellow. They're going to come in, fire green again. The far right switch on that box is a swath switch. So with row flow or V drive, and this is what Aaron kind of talked about, if your boundary wasn't quite right for the outside of the field, if there's for some reason you don't want the clutches to engage, like potentially if you have a boundary and you're planting the outside pass, you could go in here and change this to manual, or you could just flip that switch down, plant your outside pass, then you don't have to worry about getting outside the boundary, then flip it up for your second pass. On the FieldView app, you can see down below here, there's those same clutch status indicators across the bottom. If I just touch anywhere in that block, this is what pops up, and I can change it to off on manual. It doesn't allow me to do it on the demo, but I can clutch from left, clutch from right. Or here I'm actually just touching those rows. They're not actually shutting off, as you can see on the, like it would show up here, but you can see I've changed some of those. So, if you want to do it manually, you can do it from there. For loading prescriptions, if you have any shape file that you put in as thousands of seeds per acre for the rates that can be used. On the iPad, you go to home. So if I've created prescriptions on FieldView, if I've uploaded prescriptions through FieldView Web, if you get emailed a prescription and you have it on the email client on your iPad, it'll be attached and you can actually press on the file and it'll pop up open in FieldView, and you can hit open in FieldView and it will load it into FieldView. So under the fields, I could go in here. I've made a prescription for this 179 acre field, and I can assign it and assign the attribute. If I go to this bills field, we can see there's those same two prescriptions I showed after I made them online there. So I could assign that with the population attribute, and then when I make the field active, this is already assigned. The other way, going here to the demo, and if I touch here where it would say row flow or B drive and variable rate here, I can assign a prescription from right in here. So here's this prescription, and we'll do the determinant attribute. So I can do it there. This is the easiest place to assign them. Hit confirm. Apply and change to 2020. So the 2020 is actually the brain that tells the control system what to do. So this is transferring it to the 2020. So we'll apply it. And I'm not actually connected to the 2020. That's just what it would show. The simplest way to know if you have a prescription active is if I touch the field button right there, it's going to show me where I've planted. So if I've gone around the field or whatever, I can see my prescription. If I can see my prescription here under population, or if on the actual 2020 system, I can go to, on the right, there's a map. I can go to a large map and see it there with populations down here. I know I've got a prescription assigned. Okay. In the 2020, the way you would find or assign a prescription, it's under the field, so it's tied to the field. So setup, field name. I'm going to touch on the demo field we're in, and right here is where the prescription is. So if that's blank, just white boxes, nothing's assigned. So I can touch in here, row flow demo pop. In here, if you want to assign a different attribute to a different motor or a different section of the planter with V drive, you would have to do it from here, I believe. I don't think you can do it from the iPad that I found. So here's a single attribute. The whole planter is going to use one attribute, which is one layer of prescription, basically. You can make prescriptions with multiple attributes. So if I made one for one hybrid, one for another, one for male rows, one for female, whatever it might be, I could select a specific attribute per motor, or I think it's per drive section, it would say, with V drive. Motor 1, I'm going to select, say, population. Motor 2, if I had another attribute, I could select for motor 2. I'll show you quick how you would see if you had, or how you would tell if you have multiple attributes. I've got a prescription on here that I'm not able to get to the 2020, but here in the manual, this meter, it's MM truck per script. So see, there's determinant, flex, semi-flex. Those are 3 different attributes. So this is actually the way Crop Tech Consulting, Ken Ferry makes all their prescriptions. They make one prescription map with zones. And then basically on those zones, they make a layer that has different populations in the zones. And you select that. If you're one of their customers, you select that, the determinant, if you plan a determinant hybrid. If you plan a flexier hybrid, you select flex for the attribute. And the populations in the zones are going to be different for the flex hybrid versus determinant. There's also one for semi-flex. So it's basically like having 3 maps within one file, is what it would be. So if you had a determinant ear hybrid on the left half of the planter, a flexier hybrid on the right, you could select determinant for the left and flex for the right. So if you're not interested in having left half, right half, or different sections, plant different prescriptions and different rates, then you just assign one prescription. The easiest way to do it is from the iPad and go from there. A couple other things you can do in here. There's, we'll start with Automatic Express. So if you want to create a prescription right on the 2020, you have the capability. You can get from here a thumb drive, soil type data for the county or counties you farm in. You can plant around the outside of the field, won't pass, put the thumb drive in, come in here, and if you touch the button that says Get USDA Soil Map for Field, and probably it's going to take at least 5 minutes, but it'll pull the soil type data for that GPS location inside where you've planted. If you made one pass, it'll pull that in, and then you can select a population for every soil type in there. If you import a prescription from anywhere, SMS, Agronomist, Mapshots, FieldView, Web, whatever it is, this one already had a prescription. You can come in here and it says the prescription exists. Do you want to delete it and make a new or edit? I can touch edit. So let's say I made a prescription today based on, I think I'm going to plant mid-April. I don't get a plant until mid-May. I might want to change populations. I can touch on Edit Existing Zones, and it shows me, if I do it from the thumb drive, it'll give me the soil type and their productivity index. Here it's just zones, so it shows me the populations assigned. So I can do multiple things in here. I can click on one of them and increase or decrease by 500. I can select all, increase them all by 500,000, whatever. I can select all or select one and then change by the percent. So if I say, I'm going to select all, change by a percent. Really, I just want to decrease my seeding rate across the field by 5%. Enter. We just decreased them all by 5%. My average pop is 30,700. If I change by a percent, let's increase it by 10% now. To go 5% above what it was, we go 10.0. Enter. Now my average pop is 33.7. None of my changes take effect until I press Save Prescription to Field. Now the edits I just made are done. And it's going to plant what I just created. So
How did you get to AutoMap Express? I didn't see that.
it's under the RowFlow or V-Drive button.
Okay.
So I touch that button,
I don't have those.
and then it's, Automatic Express over here.
So if you have the USDA soil maps on a thumb drive, you have to put that in every time you go to a different field, or the 2020 can't memorize that once you load it, right?
It stays on the thumb drive.
So if you plant one field and then you go to another field, you want to do the same thing, you're going to have to load that
Put it
with.
in, hit get soil type data, sit there and wait while it finds it. So the easiest way to do it is through the FieldView website.
But the only way you can do it if you aren't buying Precision Acre and doing that way is to only do it through the 2020.
Or you can use a thumb drive and import from something else. But if you,
Like I couldn't download that on my iPad and it would show up on the 2020. You can't.
not these soil type data.
Okay.
Yeah, it pulls it in. It's got to come from thumb drive each time you've made a new field.
And you have to have a complete pass around the field.
Uh,
Let's say you started at one end, planted
It's
the
gotta be,
outside, pat across the back.
quarter, it's gotta be almost complete.
You got to do at least enough to get 3 sides probably. So if I've got a square field, go this corner up, over and down, it'll pull it in. But if I just plant here and here, it'll probably give me a triangle field. The other thing here, advanced swath tools. So this is going to be if you're using boundaries, internal or external. Here, boundary. So if I want to record a boundary, I could come in here and touch on that. And if I hadn't recorded anything, it would just be a white screen and show my little arrow where I was and show the file name down below. I need to have the field I'm going to make the boundary for active when I do it. So I can't just go from field to field to field recording boundaries under one file or one field name because they only show up under the field you record them for. So I need to, if I'm going to do this ahead of time, one, I need to have RTK, GPS, or RTX, so I don't get shift between today and when I plant. And secondly, pull into a field to do it on a Ranger or whatever, make the field you're in active, record the boundary, and then when you go to plant, it'll make that boundary active. So to record, you would get where you want to be. First, it's going to record right at your GPS receiver, unless you set up an offset. Here, it's going to record directly to the right of your GPS receiver by whatever measurement you put in. You can hit the flip button and record directly to the left. So this might be useful if I don't have RTK, or even if I do and I didn't record boundary, but I got a waterway through the field, and I'm going to run the outside of the planter right up against the waterway all the way around to record. I have a 16 row and I put a 20-foot offset in. But remember, it's not recording from the end of the toolbar, it's recording directly to the right or left of the GPS receiver. So I want to start with the tractor by the end of the waterway, not the planter, and finish with the tractor at the other end of the waterway instead of the planter. Once I got that set up, we're going to start. If I'm recording the outside of a field, I use field boundary. If I'm recording the waterway or something internal, I record inner boundary. Field boundary, basically, when it's outside of that boundary, it shuts off. It'll shut the swath off. An inner boundary shuts things off inside that boundary. So if you select inner boundary and record the outside of the field, it's going to allow you to plant everything outside of the field and won't allow you to plant inside the field. So it's important to select the correct one. So this one is an example. It's got an outer boundary or a field boundary here in red, and then a couple inner boundaries. If you get to a corner, you need to maneuver around. Instead of recording as you move, you can hit pause, and then that will change and say resume. So if I pull up to a corner, hit pause, back up, square up, hit resume, it'll just snap a line from where I hit pause to where I hit resume, just a straight line. And when I'm done, this would say end or end, and I'm going to hit end, and be done recording. If you've got boundaries from some other system as shapefiles, you can pull them in. So you don't have to re-record them if you've already got them in some other system. We do have the ability, if you want to plant your headlands last, you can create a simulated one and then plant those last. It'll swath off however far you want it to inside a field boundary. But if you pull in the field, plant your end rows and then plant the interior, there's no. So if you have V drive, there's this drive motor setup. You can set up to 4 drive sections here. Basically, if I touch on drive section 2, I'm going to disable that. Drive section 1, for seating, I can select whatever rows I want to here. This is just a drive section for either manual population control or assigning a different attribute to different drive sections. So there's some guys that have been on this here with V drive, they just put drive section 1 as all their rows. And then when they assign a prescription, they're only going to assign an attribute to the whole planner, and the whole planner is going to do its thing. If for some reason you want to assign multiple attributes to different sections, or planting seed corn, different things, that's when you want to assign different rows to different drive sections. This doesn't affect how it swaths, this doesn't affect turn compensation or how it changes when it gets to the line of a prescription. It still does all that row by row, but this is merely for assigning prescriptions or assigning manual populations. So, one other thing here for V drive or for row flow with clutches, we have calibrations we can do ahead of time, in the shop, out on the lot, whatever it is. I can get clutches calibrated. Usually it gets you within a few feet, but there sometimes is an adjustment that needs to be made to fine-tune things. So to get to the place to adjust that, it's setup, systems, and then either the row flow or V drive button, they both be in the same spot. Swath control setup, and then calibration state. So if I have a gap or an overlap when I start or stop, I've got a start seeding delay and a stop seeding delay. Those are the two I would want it to potentially change. So if I am starting too late, starting too soon, that's coming out of a headland, I would touch start seeding delay. And then in here, it gives me pretty concise instructions here. If I need to start sooner, increase that value. If I need to start later, decrease the value. And if I'm on hour 0.1 is 8.8 inches. So if I'm off by 16 inches, I adjust that by maybe 0.2 and hit enter. If I had trouble with my stop, when the clutches or V drive was stopping meters, here, to stop sooner, increase, to stop later, decrease. So if you do the calibrations, do your measurements, put in your measurements here on everything. One thing I would suggest doing in your first field is after you plant one pass around the end rows, or maybe even the second, and you get to where the swath control is going to begin to engage, I would take my planter and I would back up so I'm perpendicular to my end row, and basically put it so my gauge wheels or my seed exit right here is right on top of physically my inside row of my end rows. Then if I look at the map, I can stop, and you can, on this map, you can zoom in pretty tight. And if this toolbar on here is sitting right on top of the inside of what you painted, then you know that what the 2020 thinks or where the 2020 thinks you are, where you physically are, matches. Now, if I see there's that the toolbar is back, and I can see a spot that's been painted already in front of the toolbar, or if I see a gap that hasn't been painted behind the toolbar, then I need to adjust measurements to get them to match. If I get these to match, when I start to try to adjust my clutches to fine tune them, or V drive, I can watch the map and be confident that if there's a gap, I have a gap in the field. If there's overlap, I have an overlap in the field. But if I go out there and I park out in stride, gauge wheels over the inside end rows, and on the map, it shows the planter, the toolbar up here, and then I see a gap on the map or an overlap in the map, I might be right on the money, but the map shows different. So doing that quick check would just guarantee that what you're seeing in the field physically and what the 2020 thinks are matching up. And then from there, you can use the map because it's created from seed drop, not command. You can see where the seeds are actually at. And then you can adjust those numbers as needed. So I'd still recommend calibration ahead of time. Get out, dig to verify, do that check. And then once you think you've got things right where they need to be, you'll be set. All right, so if we go into setting up dashboard buttons, so setup, systems, display, dashboard buttons, and then select here. There's this low speed start button. And there's a disagreement on what it's for. So if you look up here, low speed start allows the motors to start sooner when acceleration is not detected. When this feature is active, the motors are more susceptible to false GPS and radar signals. Ensure that you're ready to start planting before activating. So with V-Drive and RowFlow, we use radar, GPS, and accelerometers to determine when we start our motors. So like John Deere planters have a wheel speed sensor. When they see the wheel move, they'll start motors. We have accelerometers like the power distribution module on the planter there, or the RowFlow module has an accelerometer. When we sense acceleration plus 0.3 miles per hour, both of those, then we'll start motors. So if for some reason the accelerometers go out, or you don't have radar or something, you should enable this low speed start. Now, people in the field will say, I have all those things, and when I enable the low speed start, pull out of the corner, it allows the motors to start sooner. So if the situation would be if I back into the corner, lower the planter, let the clutch out and go, and it seems like it takes 5 or 10 feet for motors to begin, and I have a gap, you could enable low speed start. And basically you back into the corner, set the planter down, touch the button, it'll give you, I think it's 8 seconds, which the speed threshold at which we start the motors is going to be lower. So they should start sooner. So here, if I hit low speed start, you can see it counts down 8 seconds. So basically that threshold for movement is lowered for 8 seconds. So push it when you're ready to start, let the clutch out. I will show you, if you touch on setup on the right, and then up at the top there's a diagnose tab. In here, if there is a problem, you've got a row not planting, if it says can't detect the SRM on this row, can't detect motor 1 unresponsive, any type of issue, if you touch setup and then diagnose and look in here, you don't need to be an expert on trying to troubleshoot the system, but if I tap any blank area for legend, basically green, this line green, means a device is detected and it's functioning correctly. Yellow, a device or something with it is not functioning correctly. Red means it's not working or we don't see it. Okay, so if I tap to close that, these 4 rows are white because something's detected but not set up. Once everything's set up, okay, RowFlow is red. So if I touch on RowFlow here, I can see I've got some voltage issues there, right? I don't expect any of you, except for him and me, to be able to go from this page and try to figure out what the problem is. What I would ask of you is, I got a low voltage warning. Please go set up, diagnose, see what's red, and if you touch on what's red, it'll give you an idea. And then pick up the phone and say, I got a low voltage warning on the diagnose page under RowFlow Diagnostics. Under power input, all the voltages are 0. So for instance, if we back up to this first page, if we had row 5 was red, and seed data was red, and we touched there, and then we saw this whole line across here was red. So there's 2 ways that situation can happen. The symptom would be, I got a row fail on row 5 on my 2020, it said not planting. I called Aaron and said, yeah, row 5 on my planter is not planting. What do you think I should do? Well, there's many different directions to go with that. One would be, well, let's go back and open the hopper and see if it's got seed in it. Let's pull the seed tube and switch a sensor with the next row. Let's dig and see if we can find seed. But if you say I got a row fail on row 5 and said it wasn't planting, I hit the clutch, I stop, set up, diagnose. Now 5 is red and seed data is red, and then row 5 across here is red and everything's blank. The phone call, row 5 said I'm not planting, and on the diagnose page, 5 and seed data was red, and on seed data level 2 diagnostic diagram, the line across there, row 5, is just solid red. Oh, okay, we don't detect the seed sensor on row 5. How about you get out, walk back, check the plug. Let's unplug it, see if the pins look good, plug it back in, and then we'll go up back to the cab, reset modules, and see if we detect it. Well, I walk back there, I unplug it, and I look at the harness in the parallel and I pinch the harness. I know exactly what that is. So it's going to make the troubleshooting call easier and shorter if you can at least get to this diagnose page and give some indication of what's red or what's yellow. So I don't expect you to be able to diagnose any of these systems, but if you can at least get to this page and tell us what's going on, we'll direct you to get to some different things. Because on the seed data, I mean, it's pretty interesting. We can see what style of seed sensor is it, what's the actual population on the row, what's the simulation, seed release index, what's the seed count, is the master plant switch on or off, what is the accelerometer and the SRM on that row read, or in the PDM reading, so GPS speed, the lift state, we can see a lot of those different things. If I touch on smart connector, here we can see is everything detected or not. And if I touch on load cell, here we can see cal factor, reference value, status, what's the actual reading. We can see a lot of these different things. So there's a lot of things that we can do to help troubleshoot. You don't need to know it, but if you get back to this page, it's very helpful.
Touch on system log too.
Yeah.
So this, I've taken, it's inevitable every year. Oh, there's a pop-up on my screen. What did it say? I don't know. I just did okay. Well, this is where you, this is where you can go back and look and see what this is a log of what the last thing was. So I may ask you to go back to this page, or you could go back there if you're curious yourself on what it said.
So there's things like here. Height sensor out of range. The height switch reading is more than 5% outside the calibrated range. And it tells you some different things that can be done. Delta force disabled while planting. So we see seeds dropping, but delta force is disabled, and it would have given you a pop-up. Row fail. Power off. Started 2020 seed sense, version 2015.0.9. Powered off. RFM communication error is high. And even in here, if you get really good at it, unplug the CAN connector from the RFM for 30 seconds and then reconnect. It gives you ideas of what to do to check. I guess one other thing that might be important for RowFlow V drive, down here at the bottom, this is called the dashboard mini chart. And if you touch dash view over here, you can select what you see, or you can select auto scroll. If I select auto scroll, it's going to scroll between these every few seconds. Now, those clutch status indicators only show up on the population chart. So right here I have simulation selected. So here you can see the clutch status indicators across the bottom. And you can see what happens when you have your GPS measurements wrong. See, the center of the plant is planting about 20 feet ahead. So here it's on simulation down here at the bottom. Anytime a clutch or a V-drive motor is shutting off a meter, this down here is going to change to population, and that dash view button is going to change to active clutch. We'll watch here a little bit. So whether this is set to one thing all the time or whether it's scrolling, when the clutch is engaged, it's gonna say clutch active and switch. Okay, and then it's gonna switch back. Now, I can select population all the time, and then those are always there. Okay, so now I'm always going to see my population bar graph, and I'm always going to see the clutch status indicators down there. So your choice, but it will switch to population when a clutch fires, and then switch back to whatever it's supposed to be on after the clutch is no longer active. And there's stimulation. So there's switch with active clutch. Now it's back to simulation. Or you can set it up, change it to auto scroll. Now, the simulation, active clutch, ride, spacing errors,
That's pretty neat.
population. So it's just the bar graphs that you would see if you touched any one of these boxes. So for switching crops with row floor V-drive, so setup and then crops. So this is important. So we talked about if you have a split row planner, you need to change here. But for row floor V-drive, showing hydraulic drives and clutches, here for corn, my seeds per meter revolution. So for V-drive it's 27. You set 30 in default motor population. I'm going to set that for corn. Over here, coverage pattern. This is what we were talking about. I can choose on the right side, because with this demo with row flow, it's 2 row clutch sections. So I can choose underplant, 50-50 or overplant. And then on the left side, you can choose, do I want my last seed coming into my end row to be right on top of it, 1 row or 30 inches or 20 inches, depending on your row spacing, or custom. You can do like half a row, 2 rows, whatever you want there. And I can hit enter, and also the quick adjust population. That was the plus or minus 500 on the control page. How large do I want that number to be that I adjust by? Now, if I go to change crop in soybeans, I want to set everything for soybeans. So for soybeans, you know, seeds per disc, V set would be 80. Default pop, maybe 130. Quick adjust pop, say 2000. And my coverage pattern, if I want to change it, I can change it. Okay, so we see all that. Change crop to corn. See all these settings have changed. Change crop again, back to soybeans. All these settings change back to my beans. So if you set them up correctly in here for corn or for beans, then when you change your active crop, all these settings change with it.